All right. Happy Monday, everybody. I hope that you guys are doing well and had a good weekend. Today, we're going to talk about describing data. There's been a couple questions so far that have said to describe the data using the measures of central tendency or the measures of variability. We're going to see that a little bit more in these, you to describe the data. And I want to kind of hit on a little bit more on what that means and what that's really asking you to do. Okay, so let's look here. We have three vocabulary words that we've seen before: cluster, gap, and outlier. These are three that were in our notes last week, but I want to go back over them because they're very important to know and to be able to identify in a graph. Okay, so the first one is cluster. A cluster is when the data seems to be gathered together in a particular around a particular value. Okay, so right here, I would say on our graph that really between 60 and 65 is one big cluster. But if you really wanted to narrow it down, you could say just between 60 and 62. But this would be our cluster. Okay, when you have a lot of data points together all around the same number, that's what we would consider a cluster. Okay, now a gap is areas where on a graphic display where there are no observations, meaning that there are no data points. So in this dot plot, for example, my gap would be between 55 and 59. There are no data points between there, so this would be considered a gap. This is a gap in the data. Okay, it means there's no data points there. There's also a small gap at 66, but this would be your main gap that you're looking at because 56, 57, and 58, none of them have data points. Okay, and then the outlier would be an observation that is numerically distant from the rest of the data. And we've talked about that before. You know, if someone is a liar, they're lying to you, you're not going to believe them. They're not accurately telling you the truth. Just like in this data set, 55 right here, this would be our outlier. If I wanted to know the average daily temperature outside and I was like, oh yeah, it's 55, that would not be a clear picture of what the actual average daily temperature is of this area, because the majority of our data points are between 60 and 65. Okay, that could be up to a 10-degree difference, and that makes a huge difference when we're looking at data. So just make sure that you keep that in mind, that an outlier is going to skew your data a little bit. And I'm going to talk in just a second on what that looks like and what that does to our measures of center. Okay, so just know that an outlier is something that's very distant from everything else. A gap is where there are some numbers that have no data points in between. And then a cluster, that's when all of our data points are all in one area. So really, like I said here, between 60 and 62, that's our big cluster. But we could extend it to 65 since these have quite a few data points as well. Okay, now I want to introduce three more vocabulary words, or three more words that we can use to describe data. So these are the words that I'm looking for when it asks you to describe a data set. I'm looking for outlier, cluster, gap, but I'm also looking for, what does the distribution look like? And distribution here just means, how is the data distributed? Is it evenly distributed? Is it skewed one way or another? Okay, so here we have a picture on the right of a symmetrical distribution. So what this means for it to be symmetrical is that the left side of the distribution mirrors the right side. So see how here the left and the right look pretty much the same. Okay, I think in this graph they really are the same. They don't have to be exact for it to be symmetrical. However, when you look at it, you look, okay, my left side is pretty even with my right. Okay, so the left side mirrors the right side, okay, for symmetrical distribution. And when we're looking at that, our distribution really impacts our mean, our median, and our mode. most specifically the mean and the median. If we have a symmetrical distribution, our mean is going to be approximately the same number as our median. They might not be exactly the same, but they're going to be very, very close to each other. Okay, sometimes they will be the same, and that's how you really know that your data is symmetrical. Okay, now if your data is not symmetrical, it's either right skewed or left skewed. And what I want you to remember is just that if it's right skewed, that means it's long right tail. Okay, so you see how when I'm looking at this data set, I come up and then I go down and I have kind of a longer tail going to the right. Do you guys see that? How we go to the right a little bit? That is right skewed because we have kind of a tail on our right side, more data points coming down on our right side than we do on our left. Okay, now what this does to our measures of central tendency is it makes the mean higher than the median usually. So here, because we have some of these higher numbers going into our mean, that's going to pull it up a little bit. Whereas the median is still probably going to be a little bit lower because of the frequency, the amount of data points that we have over here. This is where the bulk of our data is. Okay. And then for left skewed, when we're looking at our distribution, it has a long left tail. So this is a dot plot. So what it would look like on a dot plot would be how we have this long left tail leading up to our data point. And what that does is with these lower numbers 2 and 3 here, that's really going to bring your mean lower than your median. Because if we're looking at this, our median's probably going to be around this area. If I had to guess without counting all the numbers, it's probably going to be around here. Well, these 2s and 3s and 4, that's really going to bring our mean down. So our mean is going to be a lot lower than our median on this one. All right, so those are the 6 different vocabulary words. You obviously are not going to use all 6 in describing one data set because on this page, you only can have 1 or the 3. A data set is either symmetrical, same on the left and the right, with the mean and the median being about the same. Right skewed, where we got a little bit of a tail going to the right end and it makes our mean higher than our median. Or left skewed, where we've got that tail coming to the left and it makes our mean lower than our median. Okay, so just make sure that you guys remember that and use those vocabulary words when you're describing data.